Hello and welcome to the video on feature scaling. In this video, I'll tell you about a very important technique in machine learning that will be useful in your data analysis and ML journey. So, feature scaling is a technique to standardize the independent features present in the data inside a fixed range. This step is performed during the data preprocessing part. The most common feature scaling techniques are normalization and standardization. So first of all, before moving into the technical details of feature scaling or standardization or normalization, I'll try to explain why do we need feature scaling with the help of a practical scenario. Let's say you're trying to build a machine learning model, and the features that are used as an input for that model are age of that person and the salary of the person. Now, if you try to compare the absolute magnitude of the numbers, the age will be somewhere around the range of 25, 35, 40, 50, or max to max 80, 90, or 100. But the range or the absolute magnitude of the salary numbers will be 100,000, 200,000, 90,000. And so the difference between the absolute numbers of different features will create an impact on the decision making of the machine learning model. And so to avoid that, we are using feature scaling. Now let's understand this with the help of this beautiful picture. So here in on the left side you have your original data, and it is we haven't done any scaling or normalization on that. Now if we apply normalization on the original data, what normalization will do, it will bring all the data points in a certain range of 0 to 1, and if standardization will bring them from -1 to +1. So this is how feature scaling works. Now let's start the first technique of the feature scaling, the min max scaler, right? So before that, let's create our sample data set. So here I have made one sample data set. In this data set, I am using two features as I told you in the example. I'm having a list of fruits: orange, apple, banana, and grapes, and I am having the weight of that fruit and price of that fruit. So if you have a very close look at the data, the values for the weight of the fruit is higher compared to the price of the fruit. So this will create an imbalance, or this will impact the decision making of the model based on the values of different features. And so we are learning how to avoid that with the help of this min max scaler. So first of all, let us understand the formula of min max scaler. The new data point for the min max scaler will be, if it will take that particular data point and it will subtract the minimum value for that and will divide that by the difference of the maximum and the minimum. For example, if I want to scale this feature, so what this will do, x will be 15 and minimum of x means, so minimum of the entire column, so minimum will be 10. So 15 minus 10, and will divide it by maximum minus minimum. So the maximum value for the column is 18, and if we subtract the minimum 10, so it will be in the denominator will have 8. 18 minus 10, 8, and on the numerator will have 15 minus 10, that is 5. So this is how min max scaler works. Transform features by scaling each feature into a given range. This estimator scales and translates each feature individually such that it is in the given range on the training set. Example, between 0 and 1. Now this scaler shrinks the data within the range of -1 to 1 if there are negative values. So we can set the range like 0 to 1, 0 to 5, or -1 to 1. The scaler responds well if the standard deviation of the data is very small. So this is very important point that you can remember. This type of scaler will work very good when the standard deviation of data is very small and when the distribution is not Gaussian. And another most important thing is that this scaler is sensitive to outliers. And how do we implement min-max scaler in the sklearn? So from sklearn.preprocessing we'll import min-max scaler, and I'll make this object of a scalar object of the min-max scaler, and then I have my data frame, the fruit data set that I already showed you, weight, price, and of the fruits. And then here I'm plotting the values of the data set before and after scaling. So if you have a close look on this plot, these three are the original data points, these four are the original data points before scaling, and as you can see the difference between their values that it is creating without scaling. Before scaling, all the star marks are the data points before scaling, and once we perform the scaling, then the data is scaled to proper units. So this is how min max scaler works. Now let's move to the next type of scalar that we'll see, that is the standard scalar. So the formula for standard scalar is the data point minus mean divided by the standard deviation of the column or the feature that we're trying to scale. So the standard scalar assumes that the data is normally distributed. This is an important assumption that we should keep in our mind. This scalar assumes that the data is normally distributed and within each feature and scales them such that the distribution is centered around 0 and with a standard deviation of 1. So this is a very important interview question. They'll ask you that what is the distribution and the standard deviation of the new data points that you get after performing the standard scaling. So the distribution is centered around 0 and the standard deviation will be 1. So centering and scaling happen independently on each feature by computing the relevant statistics on the samples in the training set. If data is not normally distributed, this is not the best scalar to use. So we can check whether the data is normally distributed or not. If the data is normally distributed, then we can go ahead and work with this scalar. Now again, we will use from sklearn.preprocessing import standard scalar. For we also had the min-max scalar and now we have the standard scalar. Both are from sklearn.preprocessing. Again, we'll create one scalar object for standard scalar. Same data set, fruit, prices and weight. Now here I am plotting another plot. As you can see, this time these are the original data points with the star marks, and now here I have the standard scaled values. So the mean of this data will be centered around 0 and the standard deviation of the scaled data from the standard scalar will be 1. Now another very important question is that should we use or should we perform feature scaling on each and every machine learning project that we're doing? The answer is no. Algorithms like KNN or maybe some regression or maybe a clustering algorithm, if you're working with them, and one more thing, if you're working with neural networks, then scaling should be done each and every time. But if you're working with algorithms like random forest, decision tree, the tree based algorithms that don't have the weightage of individual numeric values of different features, then standard scaling is not required. I'll repeat this important point one more time. If you're working with some tree based algorithms like random forest, gradient boost or decision trees, then scaling is not required. But if you're working with algorithms like KNN, neural networks and maybe some clustering algorithms, then feature scaling should be done in each and every machine learning project. So I hope you are clear with this concept of feature scaling. Now let's move to the next video.